And the Sp1 benchmark, I think it was released in 1980. The idea was to compare the performance of several simulators. In fact, you can download the paper from One Petro and have a look at the original paper. This image is, I should have given the credit to the paper, but this image is from the original paper. And the model is basically three layers of sort of a layer cake with 3 layers, layer 1, 2, and 3. And there is a gas injection at the top of one of the edges of the model, and there is oil production at the other end. And as you can see, the resolution of the model, it's actually, if I show you, actually let's type it here. The resolution of the model, it's as the original one, it's 10 by 10 by 3. We have 3 layers and 10 by 10 cells, and we have equal porosity, or porosity is the same across the whole layers. This is the thickness of every layer. As you can see, the first layer, it's the thinner than the last, which has 50 feet. And permeabilities are not equally distributed, but within the layers, they have the same value of permeability in area permeability. There is this defines a KV/KH ratio between the layers, and we have initial water saturation of 0.12. And what we have done is modify the Sp1 with adding much more cells. And what we would like to do today is show you the results of the data and one of the sets. We have done quite a few modifications to this set to have a look at the effect of a grid resolution, the effect of changing different properties, and the effect of changing in this case the connectivity. So and I'm going to go into the details of what we're really changing here. Simulation workflow, it's pretty simple. We selected some variables for sensitivities, and those variables are I'll show you the variables in a second. We parameterize a simulation file in Python, and conducted experimental design through Python as well, and we run cases and finally analyze. The only thing that we're going to cover here, because the purpose is not going through the details of all this, the only aspect that I'm going to cover here, it's this aspect, the analysis part. So the idea is to for you to have a look at how we can analyze some of the results, bring the data into Python and bring the data into Orange and see what we can do. And we want to analyze some technical and also, let's say, technical variables and also technical and computational variables. Let's call it like that. And the idea is to see some of the effects of changing all these properties and into the several measured values from the simulation results, like injected pore volume. In this case, the injected pore volume, the number of iterations, the average number of iterations per time step, to understand the computing challenges that the model is, the simulator is going through, and estimated ultimate recovery. So this is a workflow. Again, we're going to focus on this. And just to give you a bit of a more introduction of the information, if in this particular case, in the parameterized file, what we have, this is the Sp1 case, the first Sp comparative solution. And what we have is some variables that we introduced in the model. We added some sensitivities to the grid resolution. And so for this particular example, the variables, and let me introduce straight away the variables that we are working with here. Let me see. Just want to make sure that it's clear what are we really changing on these models. Let's see. I'll show you in a bit, but we have mobility ratio. We have the permeability and porosity fields that we have changed as well. So at some point in the file, mobility ratios through the relative permeabilities and some values and we also changes viscosities on the PBT. And as you can see, we are pretty much calling include files to change the PBT file and to change relative permeability file. And finally, I don't know where I see let me see, okay, and then the grid properties. So if I show you the grid properties, for the grid properties, it's like really a lot of files. I don't know if you can see that, but you have quite a few files, include files where we change the mean permeability, we change the standard deviation of the permeability, we change the orientation of the distribution through geostatistics, and so on. Okay, so that's again, that's the purpose is not to go through the details of that. So the way in which we did it with this file, and this is I'll show you very quickly. We parameterize with the parameterized file. We started changing all the variables in the parameterized file, and we have also I am not going to show the experimental design that we did in Python and the replacing of the variables. That's not for the purpose of the show, of what I'm going to show today. But what I would like to show is what you can do in Python and what you can do in Orange with the analysis. So if I go back to the slides, and let me introduce quickly Orange. So Orange is really something quite nice and very. It's an application. It's a full application that has its own Python libraries, and you can download Orange. It's open source, and initially it was released as a data mining tool, and it really has grown into much more than that. It has some data science. It has some machine learning as well in it, and lots of people have been developing some plugins for evaluations like time series and geospatial data. So if you want to download Orange, just go to download on desktop application. Just download the desktop application, and I'll show you in a bit how it looks like. So before we start to work a bit more in Orange, I'm going to go to the first workflow. And what we want to do is close from Orca Hub. I'm going to open Jupyter Lab. Hopefully that should work. There we go. What I'm going to do is first do some exploration on the realization, and for that I'm going to use the library for the ResInsight library. So from the last session, I mentioned that we can open simulation cases, import data using RIPS, and also let me just import So you can have a look at what are the levels of the variables that we have changed in the file. So I have an input matrix file, which is located in my drive, and this I should give you this information as all these files. They all should be found in the Orca Hub repository later on. So I'm going to import a data frame. So for that, let me use Pandas. So I'm going to import let me run this line, by the way. Import that matrix. Input matrix. So how the matrix, how does it look like? We have 73 rows, 6 columns. So we have columns with different levels of heterogeneity index, which are not really a heterogeneity index. It's a low, mid, and high. So we label 1, 2, and 3. We have a variogram angle that gives you an orientation of where the properties are distributed. Max lateral connectivity, which pretty much tell us that where we have low lateral connectivity or high. So it's how the variogram is constructed. Low, mid, and high mobility ratio. Mean permeability from low, mid, and high as well, and KV/KH ratio, low, mid, and high, 1, 2, 3. Now, ideally, we should have the input values here, and I'm not going to go through that exercise at the moment, but let me now load a couple of cases in ResinSide. I'm going to, if I have a couple of cases, let's have a look at the heterogeneity index. And I want to have a look at the heterogeneity index at a high case and a low case. So let's see how they look like. So let's load the cases 0 and 1, and I have here a small script to just return the name of the files, the simulation files. This is just nothing, just returning what it's my simulation file 1 and my simulation file 0. So what's important, it's define how we're going to open ResinSide, and for that, I'm going to open it in this path. Okay, so I have a path for ResinSide. And if you remember from previous sessions, if you attended to those, we can call the RIPS library, and under the instance methods, we can launch the application, right? So here we go. We have the application supposed to be open. Hopefully that wouldn't hurt further the machine performance, but here we have it. Now, what we want is to open those 2 cases in ResinSide, and so what I'm going to do is for case in cases names. So for all the cases in here, I want to use a ResinSide instance, and I want to load the case. For that, I'm going to load that case. Let's see what happens here in ResinSide. So great. I have the case number 1 and the case number 2. And really what I want to show you there, it's the porosity. So let me do something here. So these cases, I'm gonna store the cases as ResinSide cases, ResinSide.project.case cases, right? So I'm going to have them in here. So now it's a res inside instance. I have the cases there. And what I would like to do is I would like to have a look at the porosity in every one of those cases. So for every one of those cases, I would like to set the view, which is the case in question, the first one, for instance. I would like to get the first view, which is in res inside. You have these boxes here, these views here, so you can add as many views as you want. So if I add another view, as you can see, the first case would have 2 views. I just want to access the first view. I don't want to play with any other. So I'm going to do that one, and for the first view, what I want is to have a look at the porosity. So apply cell results, and I think I can do a static native, and I want to, from the static values, I want to get the porosity. And I want to also make sure that this is set to visible. Oops, what happened there? View, missing one argument, view ID. Oh, this is a views. Okay. So there we go. We have porosity here. Porosity here. Let me delete this one. And I have the 2 porosity values there. And as you can see, the realizations are quite different. Actually, I can do something like how can I synchronize both? Doesn't matter, but let's have a look at the properties. Still, we have 3 layers, and in this case, we have a sort of a homogeneous thickness. So it's all the 3 realizations have the same thickness for the exercises that we modify. And let's see something. And we also have a gas injector in one edge and the producer in the other edge. So if you see these properties, and if I show you the histogram of the properties, for these 2 realizations, where if you remember the first 2 realizations from what we imported in the model, we are changing the heterogeneity index. So what it means for heterogeneity index, it means that, so this is the first case. Let me have a look at the second case. So the case number 0 has a lower heterogeneity index, or in a way, what we wanted was to have, let's say, a more closer distribution of properties near the mean value. In this case, the mean value of porosity is 0.2. And while in these cases, we have a higher level of distribution of the porosity values. In fact, we can also, we can go back, execute this code again, and have a look at perm X. And here we have perm X as well. So this has roughly the mean value is 100 in this case as well. But you can see the distribution. The ranges of the distributions are pretty much the same, but this is more like a uniform distribution. And if you have a look at the properties in the grid, we are having a look at properties that are more sparse. So that you see that the lateral continuity here, it's we have more let's say properties are more similar next to each other, while on this one we have quite extreme values next to each other. And that's one of the realizations only, and let's have a look at a couple more. So I'm just going to close this, and I can continue working with that instance, doesn't matter, but I'm going to open another couple of realizations. Let's say we take, for instance, this is 1, 1. Let's take the 0 and the 2 and have a look at, let's have a look at the variogram angle to see if we can observe something. Actually, let's take this one, variogram angle in the realization 1 and 3. So let's run this again, 1 and 3, and let's see if we see something. Okay. Well, they look quite similar, but if you see here, the orientation of there is a difference in the orientation of the properties. This is more or less well aligned in this direction, and I think that's that the difference in the variogram angle. It's that some of these properties are oriented in a particular direction, and some others are in a different direction. So that's that. In some cases, when we have the injector and producer, obviously that promotes a more a direct path of injection, of a gas injection into the producer. Right. So far so good, and I think from that's it from the point of view of having a look at the model. The next thing, and let's do this is a exploration, and let's call it title. This is exploring data for seeing models. And this is a kind of a session. And I'm going to create a new one where we're going to now extract the simulation data. And the idea is to extract the simulation data, and I'm going to show you how I extract the simulation data in Python, and then how I extract the simulation data in Orange. Do you have any questions so far before I move to the next step? No? Okay. I'm gonna carry on then. So just create another notebook. And again, what we want to do is somehow I want to store all my realizations in a Pandas data frame, and I want to now I want to capture not only the I want to capture some of the simulation results. All right. So this is about getting the simulation results in the file. So if I go to the folder, if I go to the folder with the simulation models, there are some files. I was running this with the OpenSim simulator, and it kind of gives you the restart file and the summary file, but also it gives you some values that we can open directly into Jupyter. Let's see some of the CSV values. Let's see if they are here. Don't see them here. And they are here. Right. Yeah. So we have, for instance, we have this CSV where for every simulation case, this is what we want to measure. And if we go back to the slides that we were talking about, when we were talking about what we wanted to evaluate. So we want to have a look at the injected pore volume, the number of iterations per time step, and estimated ultimate recovery. So if I show you that Excel, So for every simulation case, we have at the end of the simulation, total pore volume, the maximum number of iterations in a given time step. We have initial fluid in place. We have ultimate recovery for, and I believe this is the oil recovery. And we have, this is a number of iterations per time step. And as you can imagine, you may want to evaluate what is the effect of all these sensitivities, changing mobility ratio, heterogeneity index, the variable angle. We want to see what is the effect of all these into the final, into the output. So effectively, what I'm proposing here is that we are going to end up with some sort of linear regression to understand the coefficients of that we are fitting, and almost like a sensitivity analysis. But I'm going to show you pretty much if I create a regression, how would you create a regression model in Orange, and how you would create a linear regression model in Python, back in Python. So that's more or less what we want to do. But first, of course, we have all these files, which are for every simulation case, we have a file like this one. And we really want to do is get all the files, and we want to get all the files with this extension, and we want to get open the CSV. Okay, so let's just for the time being, let's list the files. Oh, we need a pandas. We need NumPy here. Import NumPy as NP. Here we go. So these are all the files that we need. And now what I want to do is create a data frame that collects all the simulation results in a data frame. So I want to create a master data frame using pandas. Let's create an empty one first, and let's list what are the existing indices, because as you will notice in a second, not all the files were capable to be run, and some has convergence issues and didn't enter the simulation, didn't enter up to a final step. So what I want to do is for every one of those cases, for cases names, I want to check first if the file exists. For checking that if the file exists, I need to open the file. So let's use the OS library. So if os.path.file. If os.path.is file, then I want to check if a file exists or not. So for the time being, I want to check something. If this exists, please do something. I'll do that in a bit. If it doesn't exist, print file, let's call it S, let's call it whatever we want to call it, file does not exist. And I believe I need to pass the file name. I believe it's that way. Let's see. Okay. So what's happening there? It's I have a few files that they don't exist. And but what I really want to do is capture all the data of the files in a data frame. So with this data frame that we have, and I want to get the concatenate with the pandas, with the concat method, we can concatenate the information. So for every one of the simulation cases that we have in the CSV, I want to add them in an Excel. So imagine if you have 1,000 files, they are all in different simulation files, and now we are collecting everything into one single file, so we can evaluate the results. So for that, I'm going to concatenate the original DF, and I'm going to read, while I'll read the CSV of every file, of every case. And as you can see here, I can still, let's do this, and let's print the data frame to see what we have. See if that works. Cannot concatenate, only series and data frames are valid. Okay. Right. Oh, here we go. So if I have a look at that data frame now, I have all the files, total pore volume, CPU time, final hydrocarbon in place, all the simulation results there. And I can export to Excel. I can do whatever I want with that data frame. That's not the purpose of this. The first thing that I'm showing you here is how you do this in Python. And now I'll go in a bit to Orange. And one thing that I would like to do with these existing indices, as you can see, all these files haven't been read. So I now have only 63 rows. And I want to add a column with the index, because that's going to be useful when I have to do an extra step to merge the original data, which is not the original data, the input data, like all the sensitivities are with it, with this output data. I want to have input and output in one file. And in order to do that, I'm going to also, within this if, I want to add the index. So I'm going to add a counter here using enumerate. And what I'm going to do, it's existing indices.append. I'm going to append the index, right? And at the end, I want, let's add a column called existing indices, which is going to be equal to this variable. See if that works. Look how that's super quick to do it over and over again. And as you can see at the end, now I have existing indices there, 0, 1, 2, and it actually skipped the ones, it has 63 rows, but it skipped the ones, and it has a proper index associated to the file. That's fine. And up to that point, we have a file in Python. Now, let's compare the same workflow, or let's have a look at Orange now. And let me open a new Orange instance. Before I do anything with Orange, I'm going to just give a brief introduction to Orange. With Orange, it has a lot of capabilities of Pandas. When you load data, you can import your data directly from CSV, from a SQL database, or from an Excel. You can also connect to existing data sets. Actually, let's do a quick example. There are a lot of these data sets available, and I have one that I think that I downloaded already, the banking crisis. So if you want to have a look at what you have in that file, You just drag and drop from the output, and then you have a menu with all the options available to connect to that particular object. So in this case, I can see all the information about that particular data. And so in this case, I don't know what it is. It's year, world, develop, Algeria. I don't know what it is, but let's see if we can get something that has well, this is a classical one of the iris and the flowers. Let's get another one. I don't know, Pittsburgh bridges. Pittsburgh bridges. So there you have a data, and it's pretty much a categorical data. So it's but if you can do quite a few things with that data. For instance, you can select columns, and you can specify. Look at here, we have selected data, so you can connect the selected data or the data. So what the difference is? The difference is that if I show you, the difference is if I go back to the table and then I select this and open again the columns, you see that some of these values are shown, some of these features. So if every time I change the data, let's say if I only select these few values of the data, then anything that it's depends on that data table will change. But for this exercise, I just want to select all the data. So I can go back and select all the data. Okay. In Orange, you can also have a look, select columns, select rows, and so on. There are some things that you can illustrate very quickly. Something that I like, it's that you can paint your own data and do things like you have a couple of variables. Let's say you have a variable. I was doing an example with oil in place and EOR, and where you have a couple of variables, and you can actually paint some values to illustrate a problem. So it's very, very interesting where you have, for instance, EOR and STOIP values, and you want to add categories to those and quickly create some dummy data to illustrate a problem. And then from that, you can also have a look at the table with all the values and the categories, the class. Okay. And let's deep dive, and of course there are other things like cross plots and distributions. For instance, if I want to have a look at the distribution of the data, I can have a look at this. And of course, because there is no data selected, let me select some data in the table. So I have this table, and I have this distribution. So once I start select data from the table, you can see that this the whole workflow is executed. So it's really nice. And normally in the distributions, for instance, you can see whether you have a better fit of what is the best distribution or the best fit. This is a few of the things that you could do. One of the advantages is that it's pretty fast, and the whole workflow that you establish, it runs automatically. The disadvantage is what you see here, that's what you get. So I don't know, I haven't found a way to change the colors. I haven't found a way to change the access. So bear in mind that you have a lot of flexibility when you're working with Python. So with Orange, is what you see is what you get. And it's very nice to do a very quick exploration of the data. But at some point, you're going to begin to be limited by how much you can do inside Orange. But in order to start very quickly with data, you can do it. Now, as you can imagine, one thing that I can do from the exercise that I was showing you, it's export this data frame and import it later on, export it as a CSV and import it later on in Orange. But I'm not going to do that. Let me create a new case here so everything is clean. And let me close this one. What I'm going to do is show you how the Python scripts works in Orange. So I can add actually a Python script. A Python script, it's simply, you can run your Python script here, and it has some input data and some output data. So I'm going to talk just about input data and output data, and well, in particular, output data. So I'm going to generate the same data frame that I was creating in Python. I'm going to create exactly the same data frame in Orange, and for that, I'm going to start to copy a bit of a code. And let me comment this out. This is really annoying. Just clear outputs. Right, so I'm going to import this information inside Orange, inside my Python script. So first step, I want to import all the data. I'm going to do exactly the same thing that I was doing in Python up to this point. Now, all that is fine, and as you can see, Orange, if you run it, it will run fine. But really nothing is happening with this script. If you see what's happening in data table, you won't see anything. So what you need is to use these output variables. You need to store somehow the output data here. So at the end of a workflow, I need to do something with that df somehow. So I need to say out underscore data is equal to something df. Well, that something df, it's actually, there is a method inside Orange, and which is copy at the top. So Orange has its own, let's say, API for Python. So you have to convert your table from frame into a table for Orange. Okay. It took me a bit of time to figure this out, but this is where you get the power of using Python with Orange. These and other things that I've done with databases and so on, because as I mentioned, not when you import files, when you import data, you cannot do really everything that you may want to do. So I'm going to do this out data. Oops, something, of course, something is table from frame. I'm going to import that method, and table from frame. Oh, function which has some attribute index. What is it complaining about? Let's see if that worked. No. Okay, there we go. Now, let's see what happened here. Now I have exactly the same data frame that I have in my Jupyter notebook, which is this one at the end. Oops. So I have this data frame now in here, and I can do all the stuff that I was showing you, like having a look and just move this around. So I can create a cross plot, have a look at a couple of properties. For instance, I want to explore a bit the properties. And why do you think I cannot do anything here? Just to see if people is following up what's happening there. Can we do pressure production analysis in Orange? That's a very big question. You have to tell me exactly what you would like to do. Maria asked, what is the difference between Orange and Power BI? Very different, Maria, because as you can see here, you have a lot of more visualization for it's more statistical visualization, data mining, and you have models like that you can fit in here as well. KNN, you have linear regression, logistic regression, and so on. You can evaluate those models, predict, and it's all workflow oriented. So when you do something with your data, it flows through that workflow. And I install also time series. You have geospatial mapping as well. So it's a bit different than for visualization. There is some overlap with Power BI and Spotfire, but I guess the paradigm on the workflow and also the models for linear regressions and for the analysis is a bit different. You can, and it's very interactive. You select data and then it goes. It's a bit different. I would say complementary. So the question is it possible to plot with Plotly bokeh? No. That's another limitation. As I mentioned, Orange offers you what, well, at least as far as I am concerned, it offers you what you have in there. You can do a lot of stuff very quickly, but with what you have inside the tool. Okay. So I don't see anything here because I really need to connect just the data, not the selected data. So once I connect the data, then I can start doing some plots like input. So this is all measured data. So total port volume against the iteration, the number of iterations. There is, sorry, output data, not input data. There is no input data so far here. So I can compare EUR versus the injected port volume to see if there is any sort of correlation. And you can see that might be some cases that has an additional extra recovery factor or ultimate recovery. So far so good. We have explored some of the data, and that's fine. And what I want to do now is import the and this is where we're going to continue with the workflow in Orange. And at the end, we complete the workflow in Python. So we kind of continue. So we started loading the output data in Python. We moved to Orange, show you how the Python script works. And let's carry on in Orange. And then at the end, I will show you exactly the same workflow, how you will do it in Python. And then you kind of realize what you can do with one and what you can do with the other. So the next thing that I'm going to do is import the file. And the file that I'm going to import is the one that I show you at the beginning, which is exploring simulation data. So this file. So let's copy this file. And I want to import that CSV file. There we go. And we can do some other stuff like let's have a look at the data info. And this is very limited to what you could do. You can do things like describe in Python that it's really quite complete. So if I would have gone to the first exercise, and if I would have added, for instance, IM underscore f.describe in Python, and this is let me transpose this. You can do very comprehensive analysis, or well, you have some analysis of the data at least. So, which I think in Orange you can do some stuff like have a look at the correlation, Pearson correlation, for instance, for the data. If you want to have a look at that. So, for instance, if I do correlations. It generates, it tells you that, for instance, pretty much nothing is correlated, doesn't seem to be correlated, and that's good. Except well, that's not really a strong correlation. That's just a blob of points with that index of correlation. It's not really a correlation. But again, we were using experimental design to generate the simulation cases. We are not really taking something measured in real life and trying to find the correlation with the input value. So all these variables are truly independent, and they were generated with an experimental design. So just to show you some of the features with Orange. Now, I think it's fair also to have a look at, let's have a look at the table. And you have the variable angle. And as you can see, the variables are quite different. We have mobility ratio, low, high, and mid. And this variable angle has 0, 1, 2, 3. And this in particular has, the column is gray. As you can see, it means that it's not, it was not labeled as something that is either numerical or categorical. It was labeled almost as metadata. So we won't be able to use it as it is. So one thing that we would like to do, it's a mobility ratio. I'm going to, instead of use low, mid, and high, because later we're going to do a linear regression, I'm going to do a 1, 2, and 3 instead of a low, mid, and high, right? And for that, I can do a feature from, let me delete this. I can go back, delete this. And I would like to do a feature extraction or feature construction, sorry. Feature construction, it's let me see. So I want to create a new variable, which is a numerical variable. And that numerical variable, it's first of all, that numerical variable, let me remember this. This is sorry, let me remember what I was trying to do here. With the mobility ratio, I want to have a mobility ratio corrected. And so I'm going to create a mobility mob ratio corrected. And I'm going to use a mobility ratio, of course, but what I'm going to say is mobility ratio, it's if I'm not mistaken, one if mobility ratio is equal to low, then 2, I think it's else 2 if mobility ratio is equal to mid, else 3. Let's see if that works. Oops, didn't like it. Name mob ratio, sorry. So what I'm doing here really, it's now if you see that column, we should have, no, we don't have it. Oh, you see, it's obviously, if I have a look at this table, this doesn't have mobility ratio. But if I take the table from here, and I have a second table that I can call it whatever I want, but now I have a mobility ratio on this one. So I have the original table and the mobility ratio corrected here. So far, so good? Any questions? Yes, no? Am I by myself?
No, it's all good. Thanks.
Okay, right. So we have at least one person is listening, so that's encouraging. Now, what I'm going to do now, it's another thing to highlight is that this table doesn't have doesn't have index actually. Actually, this is not the table that I wanted to import. The table that I wanted to import has an index, and I introduced a bit of an issue with the index. So you can see I changed the file, and I don't have to repeat anything else. The whole workflow was repeated. Now I have an index, but if you see this index the index starts from 1, and I really want to have an index that starts from 0, because if you have a look at the data that we were loading here, all these simulation cases, the final data frame, when we created the data frame with the observed data, this starts from 0, but this data starts from 1. So remember that we have the output in one file and the input in another file. So this Python script, it's loading the output from simulation results. And this file, this is the actual input sensitivities. Now, I probably would like to create another feature, which is existing underscore indices, and I'm going to call it exactly the same for the time being. And I want to use for that the index, and I want to subtract 1 from the index. Okay, so now I have existing indices that goes from 0, 1, 2, 3 up to 72, which is compatible with this up to 72. Now we are talking, and we needed to do that because now what I want to do is create a new table where I merge the information from this file and the information from this file. And this is a point that we haven't done in Python yet. We will do that later on in Python. So Theodore say, following add explore NN package in the next week, and if I manage to put on a presentation, would like to present the machine learning capabilities in Orange. Fine, good stuff. If you're showing machine learning capabilities in Orange, that's great, and try to make it with Python as well, so you can show, because the idea of this, and you will see in a bit, and we're just going to run a very quick neural network. But Theodore already, we'll talk later on about this, and we can talk about which data we can use. But the idea is to show both, so people realize advantages and disadvantages, because you will see in a bit the neural network. It's good that you can run it like this, but it's also limited in terms of what you could do. Okay, so again, as a learning tool, and also as a very quick analysis of your data, it's a great tool. So we have now this data, and what I want to do is really merge the data. So I want to merge data. Again, this is selected data. I really want to merge all the rows here, and I want to take data to extract data. Let's see, oops, that I forgot to save it. Let me save this, save as. Sometimes it gives me that error, and it really hasn't been a problem so far. And I can save the session, but I think it's better just to keep saving your information. So what I want to do is I want to match the, what's the name here? Do I have a case ID to the existing indices? And now I can see that I have 63 rows, exactly as I think as the number of simulation cases that we actually have. So that it seems that the matching, the merging is working. Okay, let me expand this a bit more because we're going to be working more in orange for the time being. And the data table, let's have a look at the data table. And now we have heterogeneity index. We have all the information from the output and the input file in one big file. That's great. So far, so good. One more thing that I think we could do, it's let's clean some data, because if you see here, we have some zeros here. And I think I can, I don't know if that's going to remove the zeros, but let's see. Oh, okay. Now, perfect. We have all the data, and in fact, we can make some cross plots now with that data. We can make a scatter plot now where I can see the effect of the input and the output. So again, this is not. We have to put all the data, connect all the data. It's pretty nice to do that, but now I want to see the total. I want to see the EUR, for instance, of the model as we change the maximum lateral connectivity. And as we can see, we have actually, as you can imagine, the ones that have 0 index maximum lateral connectivity, so the ones that are homogeneous models will produce a much higher recovery factor. And this is where selection might help. So if I use instead selected data, I can go back and I want to see maximum lateral connectivity. I don't want to select the 0 values. I want to select just there we have. So we have somehow we have a big range of on the maximum lateral connectivity. We only have a value with a mid connectivity. There might be other properties that would affect in a greater way the ultimate recovery. Let's see the variogram angle. Variogram angle. Yeah, we have probably most of the cases are in the high case. Also, the range of recovery, ultimate recovery, is not really massive, the change. We can see, for instance, injected pore volume. That might be a more interesting property to have a look. And let's have a look at the mobility ratio, the corrected mobility ratio. And again, some very high values on mobility, high mobility ratio. And I don't know why we have, there might be another property affecting these values. And I think there was a mean permeability. Oh, sorry. So sorry, this is the pore volume, injected pore volume, and I wanted to change mean permeability here. Right? Obviously, higher permeability, higher connectivity, and higher injected pore volumes. So that all makes sense. But now, up to now, I think everyone understood that I'm actually merging two data sets. One that I'm reading simulation models, output data, and I'm taking the input data from a CSV file, and I'm merging everything into a file. And then I'm capable to do this analysis. Is that understood? So it's two different files here. So the part that we have done in Excel, the part that we have done so far in Jupyter, it's pretty much up to this part. We haven't done merge, the data merge, and nothing else. That's it. Now let's do something fun. And one thing that I want to do is execute a linear regression. And as you know, for linear regression, we have to first select what is it that we want to use for the linear regression itself. So, so there is a column selection here. okay? Column selection. This is going to look ugly in a bit, but I'm going to take the data from here and I'm going to put it in here just to put the workflow here at the bottom. And I'm going to actually use all the data. And next, what do we do when we do linear regression or any other machine learning technique? We have to split the data into test and train data. And in orange, there is this data sampler. So you can add it here. And you can select what is the number of samples that you want. Of course, this data is not ideal because we only have 73 cases of 72 simulation cases. Some of them fail. We want to add more data to the bunch of cases, but it's an illustration of a workflow from how the whole workflow can have a potential to integrate data from different sources and how you can extend to machine learning. So now we are doing the data sampling, and you can almost have a look at this, at the data table. Let me see, data table. We have 2 data tables. You can select 2 data tables here. One data table, it's sample data, and the other data table, it's remaining data. Let me take this. In fact, I can put them both in the same, but doesn't matter. Let's put them both in the same. Oh, no, it doesn't allow me to do the same. I have to into different ones. So I want to put this remaining data here. And what you can see now, it's on this one, we have, where are the indices here? Don't know where are the indices. Somewhere in the file, we have the indices. But it's only 51 cases, as you can see here at the bottom, while this other data, it's only the 12 cases that we use for the test and evaluation of a linear regression, the quality of a linear regression. Right. So let me delete these couple of things from here. Let's do something, and here we're going to create a linear model. And again, very limited in terms of what you can do. And this is all that you can do here. And you don't have the possibility to extend the model to incorporate interaction between variables or incorporate polynomial features. That's not in here. But very quickly illustration of what is the workflow and what you would like to do. In fact, you can almost use Orange as an illustration of what is it that you want to do in when you're discussing with someone else. What is it that you want to do with the data, and what is the data, the pipeline, the data pipeline, and what is the process, and then reproduce it in Python. But then here you have a linear regression, and this failed because we haven't really done the column selection. Sorry, I forgot about this bit. So first we have to put what are the features. And we have to put what is a target variable. As I mentioned in the presentation, we want the target variable, the things that I want to show, it's injected per volume, average number of iteration per step, time step, and estimated ultimate recovery. So I'm going to take out selected, I'm going to add ultimate recovery as a target variable, and the features are the input data, okay? So what's the input data here? So mean permeability, KVKH, mobility radio corrected, maximum lateral connectivity, variogram angle. There's only one thing that we're missing, and I'll show you at the end, and if we can fix it. So I'm gonna send that selection now. There is no problem with the linear model, and in fact I can, I can now predict with that linear model. And in order to predict, I can use now the remaining data. Okay, so I created a model with my training data, and I'm going to use the remaining data, the test data, and create a model prediction. And I'm going to create a comparison of those two models, just scatter plot. and I want to see my EUR and my linear regression, and that's awful, but it's a model that I created very quickly, and there is something that we haven't incorporated on this, but I'll show you. There is a variable that we haven't incorporated. Can you please explain again, why did you have to select again in the selected columns all data? Well, you're not selecting all the data. So these are the available variables. And because you have many more variables here, you have to put the features here and the target variable here. If I select, remember that CPU time, total pore volume, all these are outputs of a simulation model. So I just want to see what I changed, the changes that I made, and see what is affecting in the EUR. So one thing that I can do now, so if I having this, so see if I change now I want to use the other variable that we talked about was the pore volume, the injected pore volume. I believe if we put two variables there, it's sort of I don't know if it works actually. I don't know if it. I don't think it works. So we need to if we send the selection, I believe this doesn't work. We have to put only one variable at a time. So let's send again the selection. And then we have to do injected pore volume and linear regression model, right? Again, not a great match. This should be aligned in a 45-degree slope, but just a quick evaluation. And the other thing that we want to do is the number of iterations per time step. Okay, let's have a look if there is any. Oh, this is awful. This is really, oh, no, sorry. Iterations and what's the results of a regression. Something really bad is going on with that regression. I think there is an outlier here on the regression. And remember that we are taking the test data here. Now, I'm going to try to correct something. If you have a look at the test, the selected column, its heterogeneity index was an input data. And, but I cannot put it in the features. I don't think I can put it in the features. It doesn't allow me to put a heterogeneity index in the features because it's a meta, it took it as a metadata. And I tell you why in a bit. And the issue is, and let's go to the feature creation. Or let me show you first on the table what's going on. The issue is that the heterogeneity index, as I mentioned originally, it's almost like a green out or gray out, and it has some zero values there. Oops, let me save. It has some zero values there. So what I'm going to do is create another numeric variable, which is let's call it head index fixed, right? And I'm going to say, well, if I'm going to assign 0 if heterogeneity index equals to 0, else we assign the heterogeneity index itself. Okay, now I send all the data. Oops, merge data, ignore, some error in merge data. Let's see what happens here. We have heterogeneity index here. Let's see if it made it to the end. Oh, we have selected some data here actually, and let's see. Okay, so now we can put this in the metadata again. Let's see if we have heterogeneity index here. Is it there? No, it doesn't seem to be there. Heterogeneity index, that's fine. Merge data, oh, okay. Case ID, existing indices. We have to run this again. And now I think everything was wrong again. And heterogeneity index fix is here. So let's see if that actually fixed the scatter plot. Well, not really. Didn't actually improve at all the, let me see, heterogeneity index. It didn't actually improve the model. Well, so be it, that's fine. EUR, linear regression, that's awful. Yeah, okay, that's fine. I'm not teaching here how to correct your model, and this is very limited data, but just showing you the potential of the application. So is it possible to see the diagnostic of linear regression model confidence interval, p-values, etc.? That's very good information. Let's see what else we can get. If you want to see what you can get out of a model, I know that you can get the coefficients on a table. You can get the coefficients from the linear model, and I'm not quite sure if you can get like the R square, adjusted R square. If it's here, it should be somewhere and here. And I don't know if someone can Google it and let me know, but I haven't seen how to do it. Just if oh, there is a test score. Let's see. There is a test score. Oh no, that's not. That's something else. Right. So if someone can Google it and have a look, please let me know. Okay. Just give me 1 second. One second. Sorry. So if someone can see if that can be done, would be great. There are quite good videos on YouTube for Orange. So another thing that we can do, similar to that, we can do a neural network. It's running the neural network with the same features and the same. But again, this is all you can do with the neural network. There is, as far as I'm concerned, very limited in terms of what you can do. And then use that to predict. And again, we can take also the
remaining data.
The remaining data, and then check the prediction of a neural network. Let's see if that is actually better than the. Well, yeah, might be. I don't know. Well, I don't know the values. It's completely very off, actually. I don't know what to say from that one. But there you go. You have more or less a workflow. And now to close, let's go back to Python. And what we would like to do, it's actually, let me take this this case. Let me call this reading simulation data. So far so good, is it? Oh, what I was estimating with the neural network, I was just fitting a model that's just creating, as I was doing with the linear regression, I was just creating a neural network model to predict on EUR on the input data. So remember that here we are selecting what are the features and what we would like to predict on. So on the data flow, we have a linear model, a linear regression, and we have a neural network. So if I change this to injected pore volume, and send the selection, you see that both are running, the neural networks, and then everything is recalibrated. So I can see the final model and the neural network. That's the neural network trying to predict what is the injected per volume amount. And on the other side, you have the linear model trying to predict what is the amount of injected per volume. So in theory, the more cases we have, and actually the data shouldn't be like that. As I mentioned, permeability, we have actual mean values of permeability that I have to put it together for this exercise with the actual mean values for permeability and the actual KV/KH ratio. I haven't done it for in that case. It shouldn't be 1 to 3. It should be the actual values to actually have something that is predictable and add more simulation cases to the mix. But the idea is to illustrate how you can create almost like a proxy model with your neural network model and with a linear regression model in Orange. So now let's go back to Python. And I hope I'm not losing most of the people because of the time. What I'm going to do is create a linear model. It reproduces the same workflow with a linear regression. So let's try to do that very quick. I know it's Sunday, so this is a linear regression. Now in Python, oops. What I want is to use scikit-learn. I'm going to use scikit-learn for that. And I'm going to do the same thing that I've done in Orange. Let me get Orange up to here. Put it like this, minimize. You more or less remember the workflow. And we have to select some columns, and we have to do some data sampling, and so on. So I'm going to use for this scikit-learn, and there is a model selection. Import of model selection, and from model selection there is a function to split your training and your test data. And the other thing that we're going to do is dot linear models. I'm going to import linear regression. Okay, so we have those two. Right, so a couple of things that I would need here again, and actually let me first from the session where we were reading the simulation data, let me make sure that we read the simulation data in here as well. So let me repeat all these steps. Let me repeat all these steps. There we go. Okay. And a couple of things that I'm going to do from this data frame. Oh, what's happening here? Oh, NumPy is not important. There we have. Actually, I don't want to print this anymore. Let me pass this. I want to remove this column. I want to do some bit of cleaning on that data. And let me do that in a new line. So I'm going to correct the indexes exactly as I did on the So sorry, I just added a column called corrected indexes here, or existing indexes. So we have the data, and the next thing that we want to do is import the second data frame here. Let's import that data frame with the indexes, and so that's all this branch and this branch, and we ultimately have to get into the merge of the data. And as I mentioned, we have to correct the indexes. So this is just one line to correct the index. So we have, instead of 1, 2, 3, and up to 73, we have 0 up to 72. And the mobility ratio, I'm going to introduce a corrected mobility ratio, which is what we did in the fixture construction here. Okay. So I have a second data frame, and up to this point, we have pretty much this data table and this data table already fixed. Now, in order to merge, I'm going to create a data frame tree, and I'm going to do it's a merge of the original df and df2, and on index underscore corrected. See if that works. Okay, so now we have up to this point where we have merged the data, and we also have corrected the data. Now the next step will be to let's put here select features, split data into train and test, and finally fit model. So that's what we want to do. And one thing that we can do, it's we have to do, it's fix the issue with the heterogeneity index. So the values that were zeros, in fact, I'm going to eliminate them from here, and I'm going to add one heterogeneity index 1, 2, and 3. And I want to keep heterogeneity index, variogram angle, maximum lateral connectivity, and mobility ratio, and mean permeability. And this is what I want to predict on now. So if I see what I have now, I have the summary of what it's similar to what we have here when we selected the columns. We have heterogeneity index, variogram angle, so same variables, and in the predictor, in this case we selected EUR. Oops, shouldn't have run that again. Fine. Let me delete this. So in the predictor, we have the ultimate recovery. Okay. And now, final thing that we want to do, it's I'm going to use that library of split split the train test, and I'm going to use 20% of the data for the test and the 80% for the training. And this random state is just to make sure that when I run it, I still have the same training data and the same test data. So if I show you xtrain is equivalent of this data set that we saw here. Not that one. So it's when we did the linear, the column selection. It's this data sample that is going here. And the remaining data, it's equivalent to the X test. This is just a limited data. That's 20% of the data selected randomly. And now I'm going to feed the linear model. So I'm going to, let's say, that's my linear model. It's equal to a linear regression. I'm going to create an instance of a linear regression. And I'm going to say that I want to fit with the X train data. I want to fit at the Y. Okay. See what happened here. Okay. Found input variables with a consistent number of samples. Oh, somehow the X train and the Y are of the, sorry, I need to use the Y train. Of course. Okay, now I have a linear model. And I can predict, let's say, using the linear model, which is it's this step. If I want to store my predicted values with that linear model predict. There we go. And we are going to use now the the test data. Okay. And now to the end, just to finish, I'm just going to try to similar cross plot using Matplotlib. So I'm going to do, oops, didn't run that. I'm going to do plt.scatter, and I'm going to plot my y underscore predict, and I'm going to compare it with the actual data, with the test data. But what am I doing here? So it's exactly the last point where I'm comparing a cross plot of the predicted EUR, what the linear model is giving me, and what the test data it's providing. So it's pretty much this final step where we did, well, in this case, we have linear regression. We have done, let's select EUR just to make a comparison, exactly the same thing. Okay, so that's a linear model, and this is with Orange, and this is with scikit-learn in Python. Right. Sorry for the long one, and I hope it was useful. Do you have any questions on the session? Theodore, we have to talk then if you're volunteering for the next one. Are you there? Oh, he's there. The final plot then is predicted EUR versus test. Yes, yes. Thank you, Divijatano. Yes, exactly, Maria. Yeah, but with scikit-learn, you can get the metrics that Roman was talking about. So you can import the metrics method and then obtain the metrics from the session. You're welcome, Cesar. Great, Fernando. Good to see you around. Well, let me know if you have any questions, and you can connect to me in the Slack and ask me anything that you might want to discuss. Theodore, then we have to talk about what we can do next, and I think it would be great to do something with pumps, where we get data from pumps and probably electrosubmersible pumps, and then we can predict whether failure or not. But I have some data. I don't know if it's complete, but perhaps we have to check also what sort of data we can use and distribute. Okay. Well, thank you, everyone, and take care. Have a good one. Bye-bye. Thank you. Thank you, Roman. Welcome, Mari.